All right, hello, this is Mrs. Short, and we are going to talk about hyperbolas today. Now, you may or may not have heard of hyperbolas, but this is what they look like. These are your basic ones over here, and these are just some like application type pictures that have to do with hyperbolas. Now, this section, I apologize in advance that there are going to be some things where you have to jot down some things, but I've tried to make it as short as possible, and I hope I don't go too fast. I was trying to keep this as simple as possible, but the questions available in MathSpace go into a little bit of detail, so I'm going to do a couple examples that are like the ones in MathSpace, so you can follow along. And the last few examples I have for you are just like little quick, easy things, like basically identifying if you have an ellipse, a hyperbola, circle, that kind of stuff, parabola, and those are the same type of questions in the end of your MathSpace. The MathSpace should go pretty quickly after the first 2 or 3 questions. All right, so here we go with an hyperbola. There's the definition of hyperbola up there, and so a hyperbola is basically, in layman's terms, it's like 2 parabolas in a way. You can see they're opposite each other here. So this is one way a hyperbola could look. The other way a hyperbola could look is facing sideways basically. And so we'll deal with both today just real quick and let you see both. So anyway, some things to notice on here. You have your center. So the center of the hyperbola is going to be right there, and it's basically the same way that you find the center for everything that we've done so far. Then you have your vertices. So then you're going to go up a little bit and down the same amount to get your vertices. Those are both vertices. And then you have your focus inside of that. Now this is all basically changed around if the hyperbola is facing the other way. So then we'll talk about how to find those things. And then you have 2 other pieces. You have your transverse axis. So your transverse axis, it's going to be the axis that cuts through your parabolas there, your hyperbola. And then you have your conjugate axis, which is going to basically go the other way. And you notice those 2 things go right through the center. So basically the numbers that are the center of your hyperbola will be the equations, x equals and y equals for those 2 axes right there. And then hopefully you see on here you have asymptotes. These dotted lines right here are your asymptotes. All right, these 2 right there. And so basically you have one positive slope and one negative slope. The slopes, they're perpendicular to each other. So the slopes are kind of easy to figure out, but then the y-intercept might be a little bit more difficult, but we'll talk about that when we get there. All right, so let's begin. Your basic equation, like this hyperbola right here is going up and down, so that's kind of like the y-axis. So when you have a hyperbola that looks like this, it's going to start off with y. So I have y minus k squared over a squared. This is just a general format, minus this time. So notice it's going to be a minus now in our equation. Then I have x minus h squared over b squared equals 1. So look at that format and notice some things. So the things to notice here are you have y being squared and x being squared. All right, there is a minus sign in the middle, so that's unique. It's equal to 1, and notice that there can be fractions in there. Okay, all right, so now this would all be reversed, if it was facing the other way, like if the hyperbola was going like this instead, then basically these 2 things would be reversed. So you can always tell which way it's going by telling whether or not the x is in front or the y is in front. All right, so some things to notice about this. Your center is still HK. So it's the number with the x and then the number with the y. All right, and then this A and this B down here, this little piece right here and this little piece right there, that's going to tell you how far to go in the x direction and how far to go in the y direction, basically away from the center to get to your vertex, your vertices. And also it's going to tell you about your asymptotes. So I think you'll learn a lot when we go and do an example. So when you do your homework for this, you probably want some graph paper, at least for the first 2 problems that you do on MathSpace. So make sure you have some available to yourself, because some of the points you have to count boxes and whatnot. All right, so on the next page here, take a moment and pause and draw yourself a little graph. And all I need you to write down are these things that I've highlighted in red right here. So I'm going to give you an equation, and we're going to talk about it. So the equation I have for us to work on is x squared over 4 minus y squared over 9 equals 1. So draw yourself a little picture or grab some graph paper, and like I said, all you have to do for like A, B, and C is put A and write the word center, B, write the word vertices, C, write the word foci, and so forth. All right, so pause and do that, and then when we get to the next page, same thing. All right, so let's talk about this. The center. You see that the x and the y squared don't have any plus or minus with them, and so basically the center has not moved. The center is still 0, 0 here for this problem. All right, so I'm going to mark that on my graph right there. All right, the vertices. Now, you see this 4? That means I go the square root of 4. 4 is 2 squared, so I go 2 in each direction along the x-axis. So I'm going to go out 2 on the x-axis and make a mark there. I'm going to go 2 in the other direction. And then I'm going to go 3 in the y direction. So 3 up and 3 down. Now, it would be helpful if you use that information to draw yourself a little box or rectangle there, because that is going to be, our vertices are going to go through the corner of that. So we'll take a second and talk about that in a minute. All right, so now my vertices. So this thing is facing in the x direction. So it's crossing the x-axis in a way. So basically, my vertices are going to be right here and right here on the x-axis. All right, so my vertices are going to be at 2, 0 and negative 2, 0. Okay, now the foci. So there's one little part right here that I didn't talk about, and you guys know that this is a squared or b squared, and this is a squared or b squared, whichever. It doesn't really matter what you call it. But in this problem, hyperbolas, you have this little equation. C squared equals a squared plus b squared. So it doesn't matter which one's a and which one's b. You basically know one's 4 and one's 9. So you have c squared equals 4 plus 9. So that is c squared equals 13. So c is the plus or minus the square root of 13. Now, that c value, that is going to be the distance from the center to the foci. So the center is at 0, 0. And my foci are going to be right, I'm going to write it but then erase it. My foci are going to be, remember, inside the parabola that I have. All right, so my foci are going to be, because eventually my hyperbola is going to look like this on one side and this on another. And so remember, my foci is like inside of those 2 parabola shapes. So there's the foci. So if my foci are going in that direction, it's basically going to be whatever my center was, and it's going in the x direction. So I'm going to add this amount, the square root of 13, to the x value, and I'm going to subtract it from the x value. So the foci, one of them is at radical 13, comma 0, because I have basically 0 plus radical 13. Then I have 0 minus radical 13, so negative radical 13 and 0. So you don't really have to draw them. Square root of 13 is like 3 point something. So you can see how it would fit like right in here, like right there, and right over there. Okay, so you don't really need to draw them. All right, so my next part of my question is this. So again, on this next page, all you have to do is write orientation and equation and what I did in red of these things right here. So take a moment, pause, and do that. All right, so the orientation. So we talked about on the first page, when you have the transverse axis and then the conjugate axis. So the orientation of this thing is basically vertical. It is going, the no, I'm sorry. My picture is different. I was getting confused here. The orientation of this thing is horizontal. Our picture is going to be going out to the side. I was thinking about the example. All right, so that's going to be horizontal because our hyperbola is going out like that. All right, what's the equation of the transverse axis? Remember, the transverse axis is the main axis that cuts through the parabola. So it's going to be this line right here. And it's right through the center, 0, 0. So it's going to be the equation y equals 0. And the equation of the conjugate axis is basically going the other way, right through the center. And so that one's going to be x equals 0. All right, and then the equations of the asymptote. So I need to go back to my picture for this. So remember that box that we drew, all right? When we drew that box, the reason we did that is so that we could basically draw our asymptotes. So our asymptotes, if you draw from the center to the corner of that box, and then the corner of the other box, there's one asymptote, and then same thing here, and then same thing over here. All right, so those are your asymptotes. All right, so this equation up here, if you just count the boxes, it went through the center, so that's 0, 0, and so it went up 3 and over 2. So the equation of that asymptote, that line, is 3 over 2 x, and then plus 0 because it's going through the origin. And the other asymptote is the same slope, really, but opposite, so negative 3 over 2 x. And going through the center. So that'll get a little more complicated if my center is not at 0, 0. But anyway, those are my two asymptote equations. All right, so that's basically it. But then let's go do one more example that gets a little bit harder because the center is getting moved around. All right, so this one is going to be this equation for us here is going to be y minus 1 over 16, and that y minus 1 is squared, minus x plus 3 squared over 9 equals 1. All right, so we're going to do the same things. So my center is now at negative 3 for my x and 1 for my y. So negative 3 and 1. So I'm going to go ahead and put that on my graph, negative 3 and 1 right there. All right, so now my vertices, remember my vertices are going to be, I'm going to go ahead and draw my box right now so I can get that in there. The box is going to be 4 in the x direction, 4 in the y direction. So I'm going to go up 1, 2, 3, 4, so right there, and down 4. Then I'm going to go 3 in the x direction, so back to here, and up to 1, 2, 3, up to there. So if you draw that box there, that's going to help us with our asymptotes and also our vertices. All right, so this is going in the y direction. So, and the last problem, I forgot to actually draw the hyperbola. So if you want to draw that, it would go like this, kind of along the asymptotes, and like this, and like this. Sorry about that. All right, so let me get back to this one. So let's see, the y is first on this one. So that means that here is my vertex right there and right there. All right, so my vertices are at negative 3, and one of them is up at negative 3, 5, and the other one is at negative 3 and negative 3. All right. My foci, so I have to do the whole c squared equals a squared plus b squared bit here. So I got c squared, and my a and my b, a squared and b squared, are 16 and 9. It doesn't matter which is which, so 16 plus 9. And look at that, c squared equals 25. So c is plus or minus 5. So that turns out very nice. So remember, 5 is the distance from the center that I have to go up to get my foci. So that means from my center, I have to go up 5 and down 5 from the center point there, and that will be my foci. So if I'm going to go up 5 and down 5, that's my y value that I'm changing. So this x value is going to stay the same, and I have to go up 5 from 1. So up 5 from 1 is going to be 6. And then I have to go down 5 from 1, so I'm still at negative 3. And if I go down 5 from 1, So 1 minus 5 is negative 4. So there's my foci. All right. So again, I don't really need to draw them on there, but all right. So next question is going to be what's my transverse axis and my conjugate axis. So my transverse axis is the axis that's going to cut through. So remember, this hyperbola right here is going to be facing up and facing down. So my transverse axis is going to be right through here. So when I draw my transverse axis here, it's going to be right down that center line. So it's going to be x equals negative 3. And it's going to be a vertical line. And then my conjugate axis is going to be right going across here. That's going to be y equals 1. All right, so let's go answer those questions on the next page. Alrighty, so my orientation is going to be vertical. All right, the equation of my transverse axis, remember, was x equals negative 3, and my conjugate axis was y equals 1. Now my asymptotes. So I have two asymptotes, y equals, y equals. Now sometimes the asymptotes can get a little crazy, but in our problems in math space, they're not going to. But remember, you always have this equation to fall back on, your point slope form, if slope intercept form doesn't work out for you. And x minus x1. So you can go ahead and put a point in here and put your slope in there and leave it like that, and that's an equation of a line, just like any equation of a line. All right, but I'm gonna try to write it for us in y equals mx plus b, because it does work out for this one, and that's a little bit easier to see. So let's go back to our box that we drew and look at these asymptotes. So remember, my asymptote is going to go from the center out to the corner. So it's going to go from here to here, and then there to there, and then across to there. Oh, that was crappy. All right, and then this corner there. So if you look at that, and if you have it better on your paper, that slope, remember, I'm going to this corner right here, and I'm coming from there. If you count up and over, basically your slope is up 1 over 1, up 1 over 1, up 1. No, wait a minute. Let's see. Up 1 over 1. Not quite up 1 over 1. Sorry about that. So on your homework for math space, it's going to be up 1 over 1. But anyway, let's see. Negative 3, 1, up to, basically that is up to 5. Yep. All right. So let's just do it the old-fashioned way. I'm going from the point negative 3, 1 up to the point 0, 5. All right, sorry about that. Yeah, it's the y-intercept is 5, and my slope from negative 3, 1 over to 1, 5, that would be, my rise would be 4, and my run would be 3, 4/3. All right. So that should be fine. Sorry, I was making it too difficult in my mind. All right, so 4/3 plus 5. So that's the equation of my asymptote there. So up 4 over 3. Yep, and x, and then plus 5. Now this one right here should have the same slope, but it should be opposite. So negative 4/3 x, and then I will have it's crossing at negative 3. So there's my two asymptotes. So 4/3 x plus 5, and so 4/3 x plus 5, and negative 4/3 x minus, what was it? Minus 3. All right. So just make sure you draw a good picture. All right, so these last few problems here, I'm going to quickly end up here with just some things that, like on your math space, you're going to have some questions about what's going on, about like which equations go with which functions. So let me just do a few with you. So I have 4y squared minus 25 x squared equals 100. So the question is going to be like multiple choice, like what is this? And so what you want to do, if you try to get the right side equal to 1, I would divide everything by 100. So I get y squared over 25 equals x squared over 4. I'm sorry, not equals, minus. Sorry about that. Minus equals 1. Well, that's an equation of a hyperbola. All right, so another thing might be, let's look at this. Y squared plus 4y plus x equals 8. So you don't have to get this in any particular format. In fact, you know, me personally, I could tell that this is a hyperbola because it was a minus sign in between, and that's the only minus one that has a minus sign. This right here, I noticed that y is squared while x is not. And so that's a parabola. It's a parabola facing sideways, and that's all you're really going to be required to know. All right. So next, let's just do a couple more of those. Let's say I have x minus 2 squared. And I have plus y plus 1 squared equals 16. So this one is just your good old circle. Remember, that's your r squared over here. Here's your center that you're moving to. This one right here, I got x squared over 16 plus y minus 3 squared over nothing, over 1, basically equals 1. So that's your equation for an ellipse. I notice x is squared, y is squared. It has a different amount that you're going in the x direction because the amount you're going in the y direction is 1. So that's going to be an ellipse that's longer in the x direction than the y direction, so it's going to be an ellipse kind of like that. All right, and so just a couple more. All right, and so let's say you had x plus 1 squared over 25 equals what? Oh, dang it. Plus y plus 4 squared over 25 equals 1. And so you're thinking about it like, that's an ellipse, but it goes 5 in the x direction and 5 in the y direction. So you're going to have an ellipse that's going the same amount in each direction. That is just a circle. So be careful for tricky questions. And last one, let's say I had 5, x minus 2 squared minus 4, y plus 1 squared equals 20. So I don't have to do anything to that. I notice that minus sign right there. That's just an indicator that this is a hyperbola. And so if you wanted to, you could divide everything by 20 if you really wanted to see like what was going on right there. You get x minus 2 squared over 20 minus y plus 1 squared over 5 equals 1 if you wanted the true format, but you don't really need to, just to recognize it as a hyperbola. All right. Good luck on your math space, and I'll talk to you later. Bye-bye.